Welcome to the Databricks Skill Builder series. We're glad you're here.
Last month at the Data and AI Summit, we announced the new Genie Spaces product, which utilizes text-to-SQL features in Databricks. Customers love this product, but they regularly want to go beyond what Genie enables. This has become such a common request that today we are showcasing sample code that can help a customer get started from building a custom text-to-SQL model tuned to their environment that learns from their own query history. At the end of implementing this solution, customers will have an API endpoint capable of receiving a prompt and returning SQL to answer the prompt. This can then be used in downstream applications or executed against a warehouse to get a resulting data set.
Awesome. We have Robert here from the product specialist team at Databricks, and Arthur Dooner, myself, an SSA at Databricks. What we're here today to talk about is how we came to this text-to-SQL solution and like a lot of the precursors for it, and then how Robert built it. So I'm just going to quickly hand it back to Robert to talk about how the pretext for this arose outside of Data and AI Summit and some like blogs that we're building. Text to SQL, getting a lot of customer requests. So we want to make sure they understand why we're doing this and how this solution will help you in your context. So back to you, Robert.
Yeah, thank you. So if you have been staying attuned with our blog and text to SQL in general, you might have seen this before, but we released this a while ago that talks about how to improve text to SQL performance on Databricks. If any of you have ever tried text to SQL before, you can, especially if you're using a big model like GPT-4 or something of that nature, you can get some pretty good success at just sending it your table structures and getting answers back. But the accuracy just isn't where you need it to be able to put it into prod. And so what this group did is they tackled how do we go about trying to improve the accuracy of this? And then also, how do we push this to a smaller model so that we can get the same level of performance that we need, but for lower cost and at faster latency? So what you see here is you see some of the end results of what they're doing. They have instruction at the very top. They end up providing the metadata of the table to the LLM. They're providing sample records here, and then they're providing sample queries as well, as they show here, two more examples omitted, along with other questions. So few-shot learning, metadata extraction, example records, all leading down to the final prompt of asking the LLM to finish this out. This is the question, and the answer comes out. Through this blog and all their actions that they took, along with the fine-tuning effort, they were able to drastically improve their model and how it performed with text to SQL. As you see here, Llama 3 8B instruct started outperforming Llama 3 70B instruct once it was fine-tuned and had the examples and everything provided to it. So how does someone go about building something like that? Well, that's what we're going to look at today. We're going to look at our final solution first. What we would do is we would want to build a chain in this scenario. So we have our prompt coming in that would go against a vector search of prior query history. This comes in question and answer pairs in the name of questions that could have been asked and the SQL that was generated for that. In addition, we have a bunch of table information with metadata. So we have the ability to look up table metadata information through this. The one thing that we are not going to include here is sample records, more because that would require administrative access to data. Data might have various sensitivities. And overall, it would just increase the latency unless you pre-package it up into an online table or something. And then we're going to turn that into a prompt, and we're going to pass it to a text-to-SQL endpoint. That text-to-SQL endpoint could be just a generic model, Llama 70B, DBRX, but it can also be a fine-tuned model. So we're going to actually look at that as well. Let's use our query history to also fine-tune a model, building similar prompts, and then getting that data set built out and then fine-tuning that model. All of this can be done on Databricks This ends up being the pipeline that we use to create all this stuff. Our input is going to be UC table metadata information, and then our query history. What this repository actually does is it pulls query history from a couple of different sources, depending on what you have available to you. Our end goal here is we're going to be building vector search. If you're familiar with that, it's a vector index where you can do similarity searches of our query history. We're also going to build out something known as an online table. If you are unfamiliar with this, please check it out. It's in public preview on Databricks. It's a very low latent way to be able to look up by primary key tables that you have in the Delta Lake. Makes it really quick and easily accessible. You can also combine this with functions, and that's what we're going to do here as well. So we're going to extract the data, and then we're going to process it in a function, and then output it for the user. And lastly, we're going to do all this stuff to build out a training data set, and then we're going to custom fine tune a model that we can then deploy on a model serving endpoint.
So it's taking all of the like great metadata that UC is using, right? Taking all the queries that folks put into these tables and questions, right? And consolidating that into like QA pairs and allowing a space for us to really fine tune.
Yeah, absolutely. And what you'll see in here is we're going to use a lot of concepts throughout the data intelligence platform. We have AI functions that we're going to use to help us generate some of those answers. A lot of your query history that you have today probably doesn't have the question that was asked to get there. But with LLMs, you can generate a synthetic question based on the query that was written. So we're going to take that step today. We're also going to use LLMs to do extraction against the queries to be able to identify the tables. And we're going to use that metadata to really pare that down and match them up. So a lot of good work that'll be done in here. As you guys see, there's a lot of data engineering, which things always come back to, but we'll take it step by step and get you guys to the end. So all this data, or all this is available in a repo, text to SQL repo. We'll include the link with the video. There's a good explanation of how this works, links to all the features that we're going to be talking about today. And yeah, that'll get you going. Any other comments, Arthur, before I step into this?
No, just go star and like Robert's repo. It's at the bottom of this video.
Yeah, thank you. So there's two main steps to this. There's the pipeline and the model. I guess alphabetically they're in the wrong order, but we're going to start with the pipeline to do the ingestion. There's a step 0 here. I am relying on the query history that's in Unity Catalog. That table right now is in private preview. It'll be made public within a month, is what I'm understanding. And so you may not have that available unless you're part of the private preview. So if you do have it, then you'll be able to use it. If not, then you won't be able to use it. So what you'll see here is you see me referencing that table in system.query.history. If you don't have that, what I'm going to show you here is how you can actually download your query history from an API. And that's what this first notebook does. So if you step through this code, what we're actually doing is we're using the API that we have out there on the data warehouse, and we're downloading that query history. You can determine how many records you pull in. By default, I have 100 or 10,000. You might want more than that when you get going with this, but just showing how it can be possible. So as you see here with the description of what's going on, this first pipeline table or pipeline notebook, this is building out all these steps here. So what we're going to do is we're actually going to identify all of our unique tables using the metadata. We're then going to identify all the unique queries that are out there. We're doing some regex replace to make sure we're not grabbing multiple queries if someone's just changing the predicate value in some way, shape, or form. I also do a similarity check using our AI similarity function to make sure that queries are unique enough when they're run in progression by the same user. So if it's just changing a word or a term, I actually take the last query that was run and I ignore the query that was run before it by that same user. So if a user is iterating over a query, I don't care about the first ones he ran or he or she ran. I only care about the last one that was run. Then what I'm doing is I'm building a function to help me extract tables from JSON. And then I'm building a function or prompt using the AI query AI function that we provide with Databricks to be able to extract the table names from a query and output it into JSON. And so I use these two together to be able to extract all the tables from a query. To make it really easy to parse it out. And so what I'm doing here is I'm running this process to extract this data set out. And I ultimately end up with a table that has all the tables assigned to a query. And then I use that unique table data set up above to be able to identify. So if you're running a query and you're already operating in a catalog and a schema, and you're just referencing that table name, by default, I don't know what catalog and what schema that table name is related to. But if that's the only table in your entire metastore that is called that, then I know where it's located. And so I use all that to match it up. If it's not unique, then I have to throw away the query just because I don't know which table it's mapping back to. And so we don't want to use query history for tables that we can't actually identify. So that said, what we start doing after we've identified all of our tables is we want to start parsing apart the query, and we want to start building some metadata around it. So first, I'm summarizing the query itself in English. Right now, that's not actually being used, but I feel like it could be useful in the future. So I've made it available, even though it's not being used yet. And then I'm also synthetically generating a question. So this receives the SQL statement, and then it generates a question that could have been asked to get there. As you can see, the prompt is reverse engineering text to SQL, write a user question or request that would result in this query in 50 words or less. So the result at the end is I have a table with a synthetic question and the SQL statement. So you can tell where we're going with this, right? I also then generate embeddings of those questions and those statements. This is really going to be used for fine-tuning the model later on, and we'll see how that's processed. We bring it all together and we create a table that we can now use for our query search index. So this is our table history. It ultimately builds out the final solution here. And you have something that you can work with for your vector search. I also go about building out some metadata around our columns and then also around our tables. Have some notes in here where some of this stuff isn't necessarily used yet. Some of it will be used for some agent stuff that I plan on building. But the table one is definitely important right now. These are also some functions that we will be using. So get table definitions. So this will be a function that we'll use to get and then also format those table definitions for this thing. Then we also have a function here that will build a prompt. Have a little note there. You don't have to build the prompt through a function. You can use LangChain for that. But we will also use this when we're fine-tuning a model. And this way you can use the exact same process to both fine-tune your model as you do to call that model in your chain. And so that makes it really easy that if you want to tweak your prompt, you don't have to tweak it in multiple places. So this was the meat. This one becomes really straightforward. All we're doing is building out our online stores and our vector search. I really won't go through this code. You guys can research it and see how to run it. There's a lot of things in here.
It's calling a lot of like Databricks SDK based capabilities that are pretty self-explanatory when you know that Databricks tech, and you might maybe look it up and try it out.
Yep. So I would just research these two things if you don't know about them. and then come through here and execute the code or modify it for your needs. The next step is we're going to look at our foundation model training API. This is that last step of creating that training data set and then custom fine-tuning the model. What we really need is we need our data set that we're going to work with. We have our rich history of queries, but we don't have it set up correctly yet for fine-tuning. So what we want to fine-tune is we want a bunch of prompts and responses. And we want our prompts to look like this. We want it to be structured very similarly, minus the example records. So to do that, we've got to build out all these prompts and we got to do it in batch. So what I'm actually going to perform is I'm going to perform a similarity match from every single record to every single record. So that was why it was important before to calculate those embeddings and have them available. That shortcuts some of this work, so we're able to join them up really easily. And what I'm doing is I'm actually building my own similarity search function here, where I can pass in 2 different embeddings and get out a score. So this is me testing that out a little bit. You can see the score of these 2 statements coming back as 90%. So those are very similar. I say 90%, but a score of 0.9, very similar. So the following 2 blocks will pull those together. And what it does is it actually identifies the 3 most similar queries for each SQL statement that's out there. And so now I have my queries together. And then I then format it using that exact same prompt function that we created in the last pipeline that will ultimately be used in our chain later on. So this generates the exact same prompt that would be used in our chain in our deployed solution. So now we have the prompt and the response, the SQL text as the response. So now what we'll do is we'll be able to fine tune our model on this full prompt and full response. And the rest here goes into that same foundation model training API. We have documentation around this as well, but what I'm going to do is I'm going to take it and I'm going to output it to this JSON-L file in one of my volumes. We can see that out here that it got landed. And then we're going to run our fine-tuning job. I got some errors, I guess. Maybe I should have run it beforehand, but this is how it worked when I did run it. So this created the training run. I'm skipping some steps here around evaluation prompts that I would recommend you not to skip when you're doing it. But for learning purposes, this goes really great. What you can see here is when you list out your training runs, you can see all the runs that you have going. So you can see I've had a few different runs when I was playing with this. And then this is the model name that I'm going to register it to. So once again, I meant to clean this up before we did it, but this is the model name that I registered it to, I registered the model and then I actually deployed this model serving endpoint. So this field was actually from up here. I captured it and registered it out there, just deploying the model later on, and so forgot to delete that cell again. But this model serving endpoint is now deployed and has that model sitting out there. So if I were to come to my model serving endpoints, I can see my Llama 3 8B fine-tuning model that's sitting out there. What this is looking for is it's looking for a prompt similar to this, and then it will output SQL in response. That's all well and good, but that's not what we're really going to provide it. What we're really going to provide it is a question. And so that gets us to the last step here, which is building out our model. We have 3 notebooks. One is a very simple chain. All you do is receive a question and you get a SQL back out. I'm using DBRX in the background, so I do not use the fine-tuned model in this one. This one adds a concept of a filter. So if you've ever used Genie before, what you do is you provide it with a list of tables, and then you can basically limit your queries to those tables. Same thing can be applied here. You can either filter by schema or by tables, and you provide that schema filter or that table filter to it, and it will generate a query within those tables and schemas. What it's an optional filter that's provided. So what I've also done here with this LangChain one is I'm using our fine-tuned model. And I'm also providing that filter. I won't step through this code. It's more just LangChain and processing it. If you've ever built a RAG chain before, this is going to look really familiar. You can see here, this is the model serving endpoint that I'm calling, the one from our fine-tuned model. I'm building some features around it that are going to call our endpoints for online tables. So you can see I have some generic code around calling those endpoints. This is me getting table definitions. This is also me building that prompt using that exact same function that we created before. And at the end, we register it, and I'm using tracing here, so you can see an example of our new tracing features. And then I deploy it onto our model serving endpoint. And so this is the endpoint where it gets stood up. And I'll just return back to that endpoint. So this endpoint is the chain that calls our custom model. So we're going to step into that. I'm going to pull up this query endpoint. As you see, I have a prompt here. Let's see if everything spun down while I was doing this demo. No, came right out. So this is the question. And then this is the schema filter that I provided to it. So said that it had to operate within this schema. So as you see on the output, it output the customer, it's querying for the customer order item count from order ID. And then it did orders and details. So it was giving me the line items of those details. And yeah, did the group by and everything well, limited to one. So I'm only getting one customer back out. And yeah, it gives me a well-structured query here that I could then take and execute in Databricks.
And that doesn't have to be a whole separate step either. You could modify this to, in one API,
Absolutely.
serve this model, and then take that step of the selected SQL, run it against one of our serverless SQL endpoints, and then you'd have the result right there, right in that system.
Yeah. I don't have that diagrammed out, but I have something very similar where you can build an agent that can do all these things. And all you got to do is also add in the ability to execute that SQL. And then the LLM can also process the results of that. The goal that I was going with was more to mimic the Genie solution, and then we'll build additional features and stuff on top of it over time. But what Genie does is it's actually only using the LLM for text to SQL, and then the application itself executes the SQL and displays it for the user.
Exactly.
I think this is most of what I wanted to show. Arthur, is there anything else we need to touch on?
No, I definitely imagine like a lot of folks will be integrating UIs with this, building capabilities that are more custom, or putting them into a compound AI system. That was again one of the big announcements of our Data and AI Summit, the shift of we're not just fine-tuning models, right? We're using them in very specific contexts to be extremely powerful, right? To integrate into these much bigger AI systems that solve a lot of problems. So this is a really great way to solve the text to SQL based problems that you are facing in your organization. Is that fair,
Yeah.
Robert?
Absolutely. And over time, our demo environment is not a great environment for these types of solutions. We have disparate data, duplicates of data that's not very well documented, that kind of thing. If you have a better curated environment, more consistent SQL usage, perhaps you only want this to go against your gold tables, those types of things can easily be added as filters into this whole pipeline so that you're building a model that's specific to the very uses that you want to deliver it for. But you also have a little bit far reaching where you could set this up to ask a question and you don't provide a filter, and it can actually scan the entire system, the entire Delta Lake, for example, queries and tables and things like that to then deliver results for you. So I'm very excited to see what this will do for other customers as they begin to experiment with this and use this. And if you have needs to implement this in your environment and you'd like help, please reach out to your account teams. We have lots of SSAs that have expertise in this area. We can help you deliver.
I'm looking forward to seeing what you all build. Thanks again, Robert. Really appreciate the time.
Yeah.
Thanks, y'all.